Hello friends, today we would try to understand a very important concept related to placement activities, the one related to linked lists. I know this word linked list would be quite scary to such students who have tried to learn it in the past, and for other students who have not learnt it at all but who know that it's very important for placements. They are just clueless as to what this linked list is all about. Whichever way, what I would like to tell you is linked list is such an important concept for placements that each and every student who aspires to get into the industry and make it big in the industry has to have basic knowledge about linked list. I would of course start from scratch, give you the basic information and take you to the highest possible level in linked list. At this stage, what category of student you are, I don't know. Whether you have in the past tried to understand linked list and failed to understand it, or you have partially understood it but not very confident, or in the past you have tried to memorize and somehow manage your academics, or you are of such a branch wherein data structures, or in other words linked list, was not at all a part of your academic curriculum. Whichever category you belong to, what I can tell you is this, that in about 5 lectures from now you would start to feel that linked list is a child's play. You would certainly feel it. Anyway, coming back to the subject. Now, why did this linked list come into existence? Why did we require a new data structure called linked list? Because we already have array data structure. In array only we can store our data. Then why do we require linked list data structure? Please understand one thing. Array data structure has many limitations, many disadvantages. Oh, what are all the disadvantages, sir? You may ask. What are all the disadvantages? By the end of today's class I will tell you. But what I can tell you is this much, that because there is a limitation in the array data structure, that a new data structure was invented by computer scientists, and this new data structure only is the linked list data structure. Okay sir, what is it, sir? What is the limitation of the array data structure? Tell us, you may ask. I will tell you. Before that, assume this to be our RAM. I am just writing it like this for your reference. Assume this to be our RAM. RAM means numerous bytes would be there in the RAM. Numerous bytes would be there. Like this. Maybe this is 1 byte, 2, 3, 4, 5, 6. Like this, you know, numerous bytes. I have told you, a RAM is nothing but a collection of bytes. In one of my previous lectures, I have told you about this, that a RAM is nothing but collection of bytes. Of course, every byte is made up of 8 bits. That you all know. I am not speaking about the bit level. I am just writing the bytes like this. Just the bytes. Okay, sir. Fine. Understood. That a RAM is a collection of bytes, we have understood. Now, if you count, you know, totally 36 bytes are there. So maybe technically I can call this RAM as 36B RAM. Means 36 byte RAM it is. Of course, nowadays we use gigabytes of RAM. Before that we were using megabytes. Before that we were using kilobytes. I can't write kilobytes, megabytes, so many bytes I can't write. 36B RAM it is, means 36 bytes are there in the RAM. Just that is the diagram. Not only that, remember, every byte, you know, would have a address associated with it. Like how every student in a classroom is going to have a USN, or in other words is going to have a roll number associated with him for identification purpose. Like that, every byte also in a RAM is going to have an address associated with it. Address, begins from 0 onwards. Say this is 0th byte, then this is first, second, third, fourth, fifth, and so on. Like that. This is 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, 16, 17. This is 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29, 30, 31, 32, 33, 34, and 35. Remember, 0 to 35 means totally 36 bytes are there in the RAM. Okay, sir, fine. What is it that you want to tell, you may ask? What I want you to understand is that in a RAM, it's not that always all the bytes would be freely available for us. Some bytes in the RAM could have been taken up by some programs present in the computer. Every program, every software present in the computer would make use of RAM. So that way, assume that already some program is making use of these bytes. Already. Somebody is using these bytes. Just assume like that. Somebody is using already these bytes. In other words, these bytes are not freely available for me, for my usage. They are not available for my usage. Why, sir? Why are they not available, sir? Because somebody else is using. That's why. Somebody else is using, so they are not available for my use. Look at the RAM and tell me how many vacant locations are there. Watch it and tell me totally how many vacant locations are there. If you will count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 15 vacant locations are there. Correct. So 15 vacant locations are there. I am happy about it, that RAM has some space left. Though some other programs are also using RAM for their purpose, for my programming purpose also some RAM is left. Remember, nowadays what we have in our computer is multitasking operating system. I know this term may seem to be very hi-fi for a student who is not from a CSIS background. Just to simplify things, I am telling you, multitasking operating system means multiple tasks will be parallelly running in your computer. For example, you yourself, would be listening to music. At the same time, you would have given download option in your computer. At the same time, you will also be chatting with your friend. So 3 activities your computer is doing. Means multitasking it is. And remember, every task requires RAM. So for downloading also RAM help is required. Some bytes would be used. For listening to music also has to come to the RAM and only play. So music also requires RAM. And if you are typing something, that is also stored on the RAM only. So what I mean to say is that if you have a RAM in your computer, it is not that all the bytes will always be available for you. Different tasks in your program would have used different memory locations. Of course, because your RAM nowadays is of gigabytes size, certainly you will have free space, no doubt about it. You will have free space. Like as in my case, some other tasks have made use of these bytes. They are still making use of all these bytes, but still there are also vacant bytes which I can use for my programming. Okay, sir, what is it that you want to tell? Vacant bytes are there, sir. 15 locations are there. What do you want, sir? You may ask. What I want is that I want to store Sachin here. Store, sir, what is the big deal in this? Store Sachin. Why to tell this much you have given so much of a build-up? Sachin you want to store, that's all. That directly you could have told, sir, tell Sachin, create one character array called as str, and 1, 2, 3, 4, 5, 6 characters are there, and at the end one /0, null also will be there. So 7 locations are sufficient. So give one declaration like this, sir. Give one declaration like this. that I want a character array called str of 7 locations, and in the 7 locations I want to store Sachin. Of course, null also gets automatically stored. To tell this much, why so much of a built up, sir, you may ask. Okay, listening to you, assume that I will make such a declaration. Means I am requesting the operating system, please give me 7 bytes. In those 7 bytes, I want to keep Sachin. That is what I am requesting the operating system. Operating system is the boss of all the resources. Even the RAM belongs to the operating system. You may tell, sir, it is my RAM, sir, I have purchased it by paying money. You have only purchased it. But when the computer is operating, it is the OS which is the boss. In other words, you have made a request to the OS telling that, OS, please allocate me 7 bytes. Now OS will go to the RAM and see 7 bytes. It will see, and it will tell, sorry, no memory, it will tell. I know, you may be shocked. What are you telling, sir? Totally 15 locations are there. After all, we have asked for 7 locations. Why is the OS telling no memory, sir? OS is lying, is what you may feel. But no, OS is not lying. It is speaking correctly, because what you have asked here is not 7 locations. What you have asked here is 7 continuous locations. Please understand one thing. Arrays demand continuous locations. You only check the memory and tell, where do you have 7 continuous locations? Here 2 are vacant, remaining are already filled. Oh. Here also 2 vacant, remaining filled. Oh. Here 1, 2 vacant, that's it. Here 2 vacant, here 2 vacant, here 2 vacant, here 2 vacant, here 1 vacant. In other words, 7 continuous locations are not at all available for me. That is why OS told, sorry, no memory. You may tell, sir, we are not convinced at all, sir. 15 locations are there. After all, 7 locations we have asked. Whether it is continuous or whether it is dispersed, like here 2 bytes, here 2 bytes, here 2 bytes, here, what is your problem, sir? After all, 7 locations you want. Keep your data, sir, you may ask. Keep it. Let it not be continuous. Dispersed only, keep it, sir, you may ask. Okay. Listening to your words, assume I will keep my data Sachin wherever space is available. I will keep it, say. See what will happen. According to you, you know, I will keep S here, I will keep A here, I will keep C here, I will keep H here, I will keep I here, I will keep N here. Null also I should keep, you know, so null also I will keep like this. This is what, sir, even we were telling. Anyway, vacant locations are there. Instead of using it simply, you are telling, no, array is bad, it demands contiguous array locations and all that you are telling. Like this, keep it, sir, you may tell. Correct. I will keep it like this. Now, all of you think. Say I want to print it. And remember, if I want to print it, you know, I will use %s. All of you know. For printing the string. Previously in my string videos I have told you, printf %s str, I will tell for printing. Our printf is designed such that it will begin from here and it will keep on printing everything till it hits a null. That is the way our printf is designed. Long back I have told you. Printf doesn't know where to stop. It keeps on printing everything till a null is encountered. Now, how will the printf know that this is your data, this is your data, this is not your data, this is not your data, this is your data, this is your data, this is not, this is not? How will the printf know all that? What the printf knows is that starting from this point, everything I have to print till null is encountered. That is all it knows. How can it know in which byte your data is present, in which byte some other program's data is present? How can it know? Oh, correct, sir. What you are saying is correct, sir. Correct. That we can't actually keep our data like this, sir. What you are saying is correct, sir. That is what I told you previously. That arrays demand contiguous memory locations. That is only the disadvantage of an array, that it demands contiguous memory location. If contiguous 7 bytes were there, then I would have kept SACHIN null, I would have kept. In which case printf would have printed till null. No problem at all. But the problem here is we don't have contiguous memory. That is the problem. That is why when you requested like this, our OS told, sorry, no memory. Oh, correct, sir. What to do, sir? What to do means you can't keep it like this. Okay, sir, we won't keep it like this. We understood what you are trying to tell. But do you mean to say that we can't use this vacant space at all, sir? Can't we use it at all? I have invested so much money on the RAM. I have now vacancies, but I don't have it contiguously. I have dispersed vacant locations. Here a few bytes, there a few bytes, there a few bytes. Like this, dispersed vacant locations are there. So can't I really store Sachin at all, sir? You may ask. We can store it. How, sir? How can we store it, sir? You may ask. You can store Sachin, but not through an array like this. Array I can't use. Oh. Then how will you store, sir? You may ask. Listen. Like this I can store. I will store S here. But A I won't store here. Then where will you store, sir? You may ask. I will store A here. Why, sir? You may ask. What is A's address? 6. That 6 I will store here. What is the use, sir? You may ask. What is the use? I will tell you. Keep noticing. Next, C. I will store C here, and C's address, which is 16, you know, that I will keep it here. Oh. Next, I will store H here. H's address 19, I will keep it here. I will store I here. I's address 24, I will keep it here. I will store N here. N's address 27, I will keep it here. And because everything is over, here I will keep a null. Not that /0 null, not that null. This null. When to use this null, I will tell you. But this is the null that I would be keeping. I have stored Sachin. Okay, sir, what is the use, sir? You may ask. What is the use? Notice. Now if I will ask printf to print it, the printf, I can design my printf like this. First it will print S. Next it will see 6. It will go to 6. It will print A. Next it will go to 16. It will print C. Next it will go to 19. It will print H. Next it will go to 24. And it will print I. Next it will go to 27 and print N. Next null it is, so it will stop. In other words, Sachin gets printed. Sir, can we design the display like that, sir? Display function. I will design and show how to display only our data by skipping others data. I won't be displaying others data. Only my data I would be displaying. Like this I can keep my data. I am successful in utilizing the vacant memory. Though the vacant memory is dispersed, still I am successful in using it. Oh, okay, sir. We understood, sir. You may tell. Okay. If you have understood, I would just rewrite the same diagram for your reference. Again, I am just rewriting the same diagram. It is not a new thing. Same thing only for your reference. Again, I am rewriting it. Notice it. This time, all other data I won't be writing, I am not interested. I would just write whatever I am interested in. See, like this. Now, put together like this I will write off. Here also. 2 bytes separately I would not write. In a single thing only, as a single block itself I am just representing it, so that it will be easy for you also. Like this I can just represent it. Okay. So, what I can write is that here I have S and then 6. Here I have, this is only 6. Next here it is A and then 16. This is only 16. This is C and then 19. This is 19. This is H and 24. So this is 24. This is I and 27. So this is 27. This is N and this is null. In other words, what I have done in this diagram is that I have highlighted only my data. Other data I have not highlighted. Other data I have not highlighted. Otherwise, there is no difference between that diagram and this diagram. Same thing only. Only thing is in this I have highlighted my data. Oh, okay, sir. Fine. What, sir? Next you may ask. Remember, this is also our 36B RAM only. 36B RAM. Okay, sir. What is it that next you have to tell? Next, you know, again I will just rewrite the same thing. This 36B RAM only. Again I am going to just rewrite it for your reference. What, sir? You may ask. Notice it. This is one block. The second. This is the third block. This is the fourth block. The fifth one. The sixth block. Okay. Now please understand what I am trying to tell you. Here S is there. Correct. Correct. Here what is there? 6. Correct. Here 6 is there. Don't look at this 6 as 6. Don't you think 6 is the address of some location? You are only noticing 6 is nothing but the address of another memory. See, this memory location's address is 6. Or rather, this memory location's address is 6. That address is what we have kept here. Remember, when I had taught you pointers, I had told you one thing. What is a pointer? A pointer is a memory location which holds the address of another memory location. So, this is the address of a memory location. This address you have kept it here means this is a pointer. Why? Because pointer is a memory location which holds the address of another memory location. Oh, correct, sir. What you are saying is correct. This location is holding the address of this means this is a pointer. That is what I am telling. It is a pointer pointing to whom? It's a pointer pointing to this location. In other words, here A is there. Similarly, this is also a pointer only because it is also holding the address of another location. Which location's address is it holding if you ask me? 16. Oh, 16 means it is pointing to this C. That way even this is also a pointer because it is holding the address of this location. So why to tell 19 here, 19 here? To better understand, we represent it like this, that this is a pointer which is pointing to this, like that we tell. Here H. Similarly, why to tell 24, 24 here? Please understand, this is a memory location which is holding the address of another memory location. So a location which holds the address, that is what we call as a pointer. That pointer, where is it pointing? It is pointing to 24. This is I. Similarly, this is also a pointer which is holding 27. In other words, it is pointing to 27. This is null. Whatever I had written here, same thing only I wrote it here. The same thing only like this also we can write. That is what I have shown. Oh, correct, sir. We understood whatever you are telling. We were able to understand. Okay, sir. Next, what is it that you want to tell? You may ask. All of you listen. Technically speaking, we call this as a node. We call this as a node. Node, 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 node. N-O-D-E, node we call it as. Or there is another name to this. We call this as a list. This is a list, 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 list. And all the lists, they are all linked. That is why we call it as linked list. Some students who don't know, they will simply tell linked list. Linked list. It is not linked list. It is linked list. Please understand that. So when you use the word in front of the interviewer, at least use that word correctly. Linked list means it shows that you don't know anything. It is linked list because these are all lists which have been linked. So it is linked list, not linked list. Whatever it is, what I would like you to understand is that linked list data structure was invented by computer scientists to overcome the limitation associated with array data structure. Array, the problem is that it demands contiguous memory. Sometimes in the RAM, we may have memory, but not contiguous. So there is every possibility that only because the memory is not contiguous, only because the memory is dispersed, we may not be able to utilize it at all. But such a thing is not going to happen nowadays because there is an alternative to array called as linked list data structure. So if at all in the RAM you have contiguous memory, make use of arrays in the programming. If at all your RAM contains vacant memory, dispersed vacant memory, then you can make use of linked list and store your data. In other words, as a programmer, you should be good at both. You should know how to use arrays also. You should know how to use linked list also. When to use arrays also you should know. When to use linked list also you should know. All said and done, I would like you to ask one question. Good, our linked list is capable of utilizing dispersed vacant locations. Correct. That is the advantage of linked list. There is also a disadvantage of linked list. Actually, the disadvantage is visible. While you are copying this, think about the disadvantage. I will tell you what is the disadvantage of the linked list. I would be telling you. Quickly copy this as it is. Alright, I would proceed further. I hope you have thought about the disadvantage of linked lists. Yeah, please understand this. One good thing about our linked list is that it can make use of dispersed vacant memory locations. One disadvantage is that it occupies more memory to store the data. You only tell me, to store Sachin in an array, how many bytes would you have required? SACHIN null. Totally 7 bytes is what we would have required. Whereas here you only see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Totally 12 bytes we have required. We have used 12 bytes. That is the disadvantage of the linked list data structure. Why it has occupied more memory, sir? If you will ask me, it has occupied more memory because linked list can't just store the data. It also has to store the address where the next data is present. Only data I cannot store, you know. because I don't have continuous locations. In array, that is the advantage. We only keep storing the data S, soon after S, A, soon after A, C, soon after C, H, soon after H, I, N, null. That's it. Continuous. Whereas here, I have to store S. In the next location, I have to store the address. A, and then again store the address. So, each time I have to keep storing the address. Because of this, certainly it occupies more memory. Certainly, for everything that is good, there would be some negativity also attached. That way, if you look at it, array, the advantage is it occupies less memory. The disadvantage is it demands contiguous memory. Linked list, the advantage is that it does not demand contiguous memory. The disadvantage is that it demands more memory. As a student, this level of understanding is important to get into the industry and be successful in the industry. I hope all of you have been able to understand both the advantages and disadvantages associated with arrays and linked lists. All said and done, some students could have got this doubt. That, sir, we understood everything that you told, but tell us one thing, sir. Why will the operating system allocate memory for one program 2 bytes, for some other 2 bytes, for some other 4 bytes, for some other 4 bytes? Why dispersedly it will allocate memory, sir? If operating system allocates memory to programs in a contiguous manner, then like this dispersed vacancies won't be there, sir. Then we never would have required linked list only, sir. It is a problem of operating systems. Why it is allocating 2 bytes, then leaving 2 bytes and then allocating 2 more bytes, then leaving 2 bytes and then allocating 4 more bytes, then again allocating 4 more bytes, then leaving 2 bytes, allocating 1 byte. And why like that, sir? Let it allocate continuously so that all the filled bytes are on one side, all the vacant bytes are on the other side. This is a doubt which could be there in a few minds. But please understand, operating system would have allocated memory in a sequential manner only. Operating system would have allocated memory 2 bytes for this, 2 bytes for another program, another program, another program, like that only operating system allocates. But what happens is, after the operating system allocating, when the program finishes its execution, it will release the memory. Next, some other program will finish the execution, it will release the memory. Some other will finish the execution, it will release the memory. So when for the first time allocation is made, OS is going to make it in a sequential manner only, so that all the busy bytes are there above and all the free bytes are there below. But the problem is that these programs for which memory was allocated, they will finish their execution and they will release off memory. So some programs will finish early and release memory early. Some will keep on executing and they won't release, which is why pockets of vacancies will get created. It is not that OS does it intentionally. The point is that when allocation happens, everything would be done sequentially. But as and when the program for which memory was allocated, once that program finishes its execution, it will release its memory. So these 2 bytes which were vacant, previously was used by some program. It has released it, that is why these 2 became vacant. Whereas these 2 bytes was allocated and still that program is using these 2 bytes. So it is not vacant. Similarly, these 2 were also allocated for somebody. It has released it. That is why this became vacant. That is why this became vacant. That is why this became vacant. It is not that OS has allocated it in a manner where vacancies are created. OS always allocates it in a sequential manner. I hope if at all the doubt is there, it is completely clear. Another doubt a student may have. Sir, if in case I have just 1 byte, sir, according to you, minimum 2 bytes have to be there. One next to the other, minimum 2 bytes should be there, so that you can keep data in one, address in the other one. What if I have only 1 byte, sir? For example, say supposing, like this, just 1 byte I have, sir, just 1 byte I have. Now, if say just 1 byte I have, then can I keep the data here and the address here. No, that is not possible. For a linked list also, minimum you must have that much space wherein you can keep the data. Immediately next to that only the address also you should be keeping. So if there is just 1 byte, you will keep of data here. Address where will you keep? Of course, in case of Sachin, I don't want to use this byte. That's a different issue. I am speaking in general. If say only 1 byte is there, in that data you will keep. Address where will you keep? Correct, sir. Then according to this, then even linked list is not making use of memory efficiently, sir. Correct. Linked list is also not making use of memory efficiently. But when compared to array, array demands lot of continuous memory. Linked list tells, boss, give me just 2 continuous bytes so that I will have data in one and the address in the other one. To that extent, it is less demanding when compared to arrays. That is the way you have to look at it. These are all the interview questions they will ask you. Does linked list make use of memory 100% efficiently? You should tell, sir, relative to the arrays, it makes use of the memory efficiently. 100% efficiency can't be achieved, because if say there is only 1 byte, in that I will keep the data. If the next bytes are busy, then I can't keep the addresses in the next bytes. Then how can I keep the data here? Here I won't even keep the data. I won't use this byte. Rather, I will search for the next location where I have space left to keep the data and the address one next to the other. So that way, you should minimum have that much space wherein you can keep the data also, you can keep the address also. Minimum that much continuous space has to be there. I hope all of you have been able to understand whatever I had to tell. Okay, sir, we understood. What next, you may ask? Next, I would like to slightly take you towards programming. Now, this whatever is there, this node, I would like to create one node. Or in other words, I would like to ask the operating system, please allocate me memory for one node, I would like to tell. If I will have to tell to the operating system, first I should tell to the operating system what all is there in a node. You only tell me, by looking at this node, what all do you have in this node? One character data is there, one pointer is there. Oh, correct, sir. What you are telling is correct. That is what I am writing here for your reference. Notice, one character data is there, like this. One character data is there. Not only that, one pointer is there. Whether you want to call this pointer as P, or whether you want to call this pointer as Q, or whether you want to call this pointer as temp, your wish. I will call that pointer as link. Any name you can give, I am calling it as link. Tell me, whom is this pointer pointing to? Please understand, this pointer is not pointing to this character. Understand one thing, this pointer is pointing to the node. It's not pointing to that character. This pointer is pointing to the node. Oh, so link is a pointer to a node. I had previously taught you how to read declaration statements. Long back I had taught you. Using that technique, if you read it, like this, link is a pointer to a node. Correct. It is a link is a pointer to a node. But in C language, we always tell it as struct node. We always tell it as struct node. And remember one thing, that whenever, you only check this. Are they same type of components, or are they different type of components? You may ask, sir, what do you mean, sir? This is character data, whereas this is a pointer. Are they of same type, or are they of different type? You may tell, sir, what question are you asking? They are of different type only. One is character data, whereas the other one is a pointer. They are of different types only. Correct. Though they are of different type, you want to merge it and make it one entity. You are only seeing they are of different type. One is data, another one is pointer. But put together, you want it as one entity. Whenever like this heterogeneous things you have, and still you have to combine it and have it as one entity, and that is when structures are used. In one of my previous lectures in structures, that is what I had taught you. We had the name of the student, we had the marks of the something like that we had. So there also it was heterogeneous data. Here also heterogeneous only. One is of one type, another one is of another type. So that is when I have to make use of structure. So that is when I tell struct. I told you open bracket, close bracket, semicolon. Oh, correct, sir. What is the name, sir? You may ask. You can call this either as node or list. I told you. I will maybe call it as node. If you want to call it as list, call it. I am calling it as node. Oh, correct, sir. What all will be there, sir, in a node? You may ask. In a node, you only are seeing. In a node, one character data is there. Tell that. That character data is there. What else is there, sir? You may ask. What else means one pointer is there. That pointer, whatever name you want, you can give. I am calling that pointer as link. Who is that pointer pointing? An average student would think that this pointer is pointing to this character. It is not a character pointer. It is pointing to the entire node. Oh, so link is a pointer pointing to a node. But as I told you, in C language, we call it as struct node. Like this, we have to define a structure. Oh, okay, sir. We understood it. That we should define a structure like this. We understood. Fine. Now, can you tell me how many nodes have I created now? By telling like this, how many nodes have I created? Some of you would be thinking, one node I have created, which means you have not revised the previous video. I told you memory is not allocated for a structure. Memory is allocated only when you create the variable of a structure. Recollect? For a structure, memory is not allocated. I had told you. Please be alert. So when I am asking how many nodes are allocated, no node is allocated. I have only told that a node means it will contain character data, it will contain one pointer. Like that, I am just telling you the structure, that's all. I have still not allocated memory. Oh, okay, sir, we understood. Now, how to allocate memory, sir? You may ask. Ask the operating system, it will allocate you. How to ask, sir? That is what we are asking you. You may tell. Like this, you have to ask. Like this, I am asking. Notice, operating system, allocate. Operating system, allocate memory. Like that, I will ask. Allocate memory. Now, it will ask you how much memory. Operating system will ask you how much memory you want. You only check this. What is the size? I know some of you are telling 1 plus 1, 2 bytes you are telling. Correct. What you are saying is okay. But why to take that risk? You may ask, sir, we didn't understand what you mean by risk. See, why should you count how many bytes you want and all that? Why should you count? You tell of operating system only. You tell of operating system only. Operating system, please allocate memory. How much memory? If they will ask, then you only tell operating system, I don't know how much memory. There is this node, and I told you in C language, we don't call it as node, we call it as struct node. There is this struct node, whatever is the size required for that. Whatever is the size required for that, please allocate that much. Like that you tell off. Why do you want to take a risk of telling allocate me 2 bytes, allocate me 3 bytes? Why should you take that risk? Of course, here the structure is simple structure. Only 2 things are there. So easily you can tell off, sir, why all this are 2 bytes? I will only tell directly. But going ahead in the industry, the structure, whatever like this you will declare, it will have some 10 things inside it. Here only 2 components are there. Once you start doing real programming, some 10 components will be there. Why should you sit down and calculate the memory requirement of all that and tell it? Rather you leave off that also to the OS only. Tell off to the OS that please allocate memory. How much memory? There is one structure, there is one node that is there. How much ever size is required for that, that much allocate. Like that you tell off. That is an intelligent way of asking the OS to allocate memory. Oh, okay sir, we understood. Next what sir, you may ask. When you ask like this, you know, memory would be allocated to you in the RAM. Wherever vacancy is there, I don't know, this vacancy, that vacancy, this vacancy, somewhere OS will allocate you memory. Now memory is allocated, no name only for this memory. Whenever you ask the computer to allocate memory, you know, using malloc, name won't be there with it. Sir, if name is only not there, then how to access it, sir? That is why. To that allocated memory, make your P to point to it. Make your P to point to it. In other words, P is pointing to it. P is pointing to it. But what is P, sir? You may ask. You only check. What is P? P is a pointer. Again, think and answer. Is the pointer pointing to the character, or is the pointer pointing to the pointer, or is the pointer pointing to the node? Correct. Pointer is pointing to the node. So, I will declare P as P is a pointer pointing to node. But in C language, I told you node we never tell. You should tell it as struct node. Sir, why sir in C language node we should not tell? Each time struct node. Go ask Dennis Ritchie. Don't ask me. Unfortunately, he is no more. That's a different issue. Each time writing struct node is irritating, which is why in C++ we just write node each time. But in C language, this is the way it is. C++ you need not worry at all, because once you are learning Java, C++ is a waste. I hope it is completely clear. This is the way you can ask and take one memory. One node you can ask and take. So, I will just again repeat it for your reference. Please notice that if you want something like this, you know, first you should define the structure. Node means what all will be there inside it, you should define it. And once you define it, don't think that memory is allocated. I will just give you an analogy. Assume that you have seen a bike in a showroom. You will go and tell your father, father, that bike is there, such a headlight, such a mag wheel, such a disc brake system, that this, wonderful. You have explained the structure. You have explained the structure of the bike to your parent. Parent will tell, oh yes, good, that's it. You may feel that, oh, if I explain it, then he will fetch the bike. You may be thinking that the parent will buy the bike for you. But where you have not asked the parent at all. You only told the structure of the bike. It is like that, it is like this, and all that you told. Parent also told, oh, is it? Okay. What you should do is, after telling the structure of the bike, then you should tell parent, allocate bike. Oh, that is what I am doing here. OS, allocate memory. The moment you ask your parent, allocate bike, first thing parent will ask you is, hey, how much money? Money you don't know. You don't want to guess also. Simply you will tell of 50,000. Believing that if your parent goes there, if that fellow tell, no, not 50,000, it is 80,000, then there is a risk that the bike you will not get it. So don't take that risk. Why should you take that risk? Anyway, you have told the bike's name, the structure, everything you have told. So you only tell of parent, allocate memory. How much memory? I don't know. Whatever is the size of, or in other words, whatever is the cost of that bike. Bike you have told, whatever is the cost of that bike, that much you allocate. This is a safe way of interacting with parents. Use it. Anyway, notice that once you tell like this, anyway your parent, because of your wish, ultimately they will get you this bike. But when the bike you get, your name won't be on that. But you want to show to all your friends, hey, this is my bike, you want to show. How will you show? Very simple. For that bike, one name sticker you put. In other words, once the bike is purchased, one sticker you put on that bike. So technically speaking, what is P if you ask me? It is a pointer of node. That is struct node star P. How to read it? I have told you. P is a pointer to a node. Correct. Pointer to a node. Oh, okay, sir. We understood. What next, sir? You may ask. Technically speaking, this part if you want to access, then that part you can access it by telling P arrow data. This part. Long back I told you, structure, if you want to access it through a pointer, you should use arrow operator. I have told you in one of my previous videos. You cannot use dot. Dot you have to use if you are doing it without pointer. Through a pointer, if you want to access a structure, after all, this is a structure component only, you should use arrow. Similarly, this part, if you want to access, this part is nothing but the link part. But what is its name if you ask me? It is nothing but P arrow link. That is what is the name of this part. I hope you have understood how to tell to the OS what is the structure of the node. First you should tell to the OS what is the structure of the node. Means in a node what all will be there. First you should tell it. Otherwise how will OS know what all should be there in your node? How will it know? So first you should only tell what is the structure. You should only tell. After that put an application telling that please allocate. How much? That also you only find out the size and allocate. And after allocation is made, your pointer you set up to that. Oh, correct, sir. Okay, sir. We understood it. But what, sir? Only one node we have got, sir. I want to store Sachin, sir. In this only yes I can store, that's all. Sachin how to store, sir? You may ask. Oh, if you want to store Sachin, ask one node, put yes. Ask another node, put A. That node and this node, link it. Ask another node, put C. That node and the new node, link it. How to link it, sir? That is only called as linked list programming. That is only called as linked list programming. Linked list programming is all about operating on the nodes. Insert at the front of the linked list. Insert at the rear of the linked list. Delete the nodes at the front. Delete the node at the rear. Reverse the link. All these things is what you are going to learn in the next sessions. But before I get into programming on linked list, it was my duty to first tell you as to why linked list came into existence. As I think all of you have now understood, arrays had a limitation. To overcome that, linked list came into existence. I hope also the slight coding part on that which I have told is also completely clear. Please be quick, copy that. All right. So I would be proceeding further, and I think when compared to the beginning of the lecture, whether the linked list was known to you or not known to you, I don't know. But at least by the time we have reached almost the end of this lecture, you have been able to understand as to when linked list is useful, what is its advantage, what is its disadvantage. Of course, we have not got still into the serious programming aspect. When I get into programming, you will understand that also. I would like to close this session by giving you a small analogy so that you understand things better. See, before cities emerged, before cities emerged, we all used to live in villages only. The growth of cities is a recent phenomena, maybe about 150 years old. Before that, all of us were living in village only. Like that only, assume there were 5 brothers. 1, 2, 3, 4, 5 brothers. Now, identifying the brothers, like this. So, 5 brothers, these are the 5 brothers. As long as they were in the village, very simple life for them. First brother lived in this house. First brother. Second brother, sir, next house only. Third brother, sir, next house only. Next site only. Fourth brother, sir, next site. Fifth brother, sir, next site only. This is how we used to live in the villages. One next to the other, one next to the other. The advantage of living like this is no brother has to memorize the address of another brother. Why will he memorize? His next brother means next house, if he go there only next brother is there. Should he memorize the address that, oh, my next brother is, and why to memorize? Next house only next brother. Oh, correct, sir. What next, sir? You may ask. What next? Listen. Assume due to some reason, these brothers who are happily living in the village, somebody gave them an idea, go to city. So all the brothers decided, yes, we will leave this village, we will go to city. They contacted one broker in the city, telling that, look, we are 5 brothers, we want to shift to Bangalore. Please find 5 vacant continuous plots for us. 5 vacant continuous plots in Bangalore city, where will you get? I am not speaking about the outskirts. In core city, 5 vacant continuous plots if you find, 100% it is a litigation property only. Proper property, 5 continuous vacant sites you will never get. Forget about 5, I doubt even if you will get 3 continuous vacant sites. The broker in the city also, he searched and he finally told, sorry brothers, I am not able to find 5 continuous locations. Then these brothers felt very bad that, oh, we can't go to city at all, no. But this broker gave an idea. No, don't worry. I have found one wonderful slot in Vijayanagar locality. There, first brother, you can shift, he told. So the first brother shifted to this place. First brother. Instead of showing like this, I would show that in Vijayanagar locality, first brother shifted. First brother. Another vacant plot was found in Jainagar. There, second brother shifted. And the second brother's address, whatever Jainagar's address was there, that Jainagar's address was kept here. This fellow held it. Because he has to know where his brother is. Another site was found somewhere in Indranagar. So the third brother shifted here to Indranagar. And that fellow's address, he kept it. Because he has to know where his brother is. Similarly, one more fellow shifted to Marathalli. Marathalli, that address, this fellow kept. Marathalli, he kept. In other words, like this. Here the fourth brother shifted. And one more fellow, he shifted to Yelahanka. And here, these are the ones. Luckily the couple, had only 5 children. All 5 children shifted, and hence null. Very happy the village brothers, very happy that they all shifted to the city. Still they are all connected. That is the advantage. Of course, one extra burden for the brothers is that they have to remember the address. The first fellow is in maybe Vijayanagar. Just this is the advantage. Of course, don't you think in city we are living like this only? What, in the city your house is this, your brother's house, if you'll ask your neighbor's house, you think that is your brother's house? Just try once thinking that your neighbor's house is your brother's house, that is your next brother's house. It's not practical at all. In city this is the way we live, whereas in villages that is the way we lived. That is why this I called it as array data structure, contiguous, whereas this is linked list data structure. In array, traversal is easy. From here if you want to go here, I plus plus. From here if you want to go here, I plus plus, I plus plus, I plus plus. That is why in the for loop we were using I plus plus to go from one to the next, one to the next, one to the next, one to the next. Whereas here I can't tell I plus plus. How in the city you are in your house, your brother's house means I plus plus. What, will you go to neighbor's house and tell this is my brother's house? You can't tell I plus plus. Then how to go to the next one, sir? How to go to the next one means whatever address is there in your mind, use it and go to that. Programming wise how to do it, sir? That I will teach you, programming wise how to do it. But at least one thing is clear, that I can't tell I plus plus and go to my brother's house. I have to use some other technique to go to the next node. How to go, that I would be telling you. I just gave you this analogy to make you understand as to what is the advantage and disadvantage of an array, what is the advantage and disadvantage of a linked list. Strictly speaking, if you ask me, in cities we don't live as linked list. I mean, strictly speaking. So don't take this analogy as it is, because it is not that one brother will remember only another brother's address. It is not like that. What, do you people remember only one relative's address? Don't you think you remember many relatives' address? They also remember many relatives' address. So that way it is not a linked list data structure, it is called as a graph data structure. Let us not get into it. Later when I discuss, I would speak about it. One thing I want you to understand is this, that we certainly can have addresses and make use of vacant plots present in the city. Similarly, we can make use of dispersed vacant memory locations present in the RAM. I hope it is clear. Please be quick. All right. So I hope this first session on linked list has been quite informative for you. Of course, I have not started off with any serious programming. Certainly I would be starting off with programming in the next video. Thank you very much.